Hello and welcome to this screencast on the Binomial Theorem. Now what the Binomial Theorem does, it allows us to easily expand out brackets or expressions of this form. So here I've got a bracket including two terms, a plus b, and we've got a power of n. Okay, so n could be anything, and this is what we want to be able to expand out. So if I originally choose relatively small values of n, for example, n equals 2, what do I have? Well, a plus b squared, as you probably know, is a squared plus 2ab plus b squared. Okay. If you're unsure where I've been able to get that from, I suggest you have a look at some textbooks or some web pages on expanding out brackets. Okay, so that's a plus b squared. And what I'm also going to do is have a look at a plus b cubed. So if I was to spend the time and effort, which I'm not going to do now, but to expand out a plus b cubed, we have a cubed plus 3a squared b plus 3ab squared plus b cubed. And I could do the same for a plus b to the power 4. Now you might start thinking, crikey, this is a lot of work. How am I able to write it down so quickly? Well, that's the trick I'm going to teach you in a minute. That's the binomial theorem. Okay, so what we have is a to the power 4 plus 4a cubed b plus 6a squared b squared plus 6ab cubed plus, oh, not 6ab cubed, got that bit wrong, it's 4ab cubed plus b to the power 4. Okay, so there's a few examples, and as you can see, as the value of n gets bigger, we got more and more terms, and it's going to get more and more complicated. What I want you to notice is have a look at the coefficients of a squared, the terms in the middle, and the b squared at the end. Okay, so a cubed, terms in the middle, b cubed at the end. What they do is they follow this pattern. Okay, so for when n is 2, we have 1, 2, 1. When n is 3, we have 1, 3, 3, 1. When n is 4, we have 1, 4, 6, 4, 1. And this is what's known as Pascal's triangle. You may have seen this before. What you have is each value is the sum of the two values on top of it. Okay, so this 3 here is simply 1 plus 2. This 6 down here is simply 3 plus 3. Okay, and that corresponds to different values of the power n. Okay, so when n was 2, we had 1, 2, 1. Here we have 1, 2, and 1. Okay, so that's n is 3, and then n is 4. Okay, this is called Pascal's triangle. These values are actually called the binomial coefficients. So it's a binomial coefficient, and these values can actually be calculated using what's called factorials. Okay, so the binomial coefficient, I'm just going to write down the definition before talking about it. So we have n factorial divided by n factorial multiplied by n minus k factorial. Now a factorial is simply all the numbers less than or equal to n multiplied by each other. Okay, so for example 3 factorial is 3 times 2 times 1. Okay, so this is how we represent a binomial coefficient. So it has two numbers, n and k. Now n corresponds to this n here, and the k corresponds to how many values across in a row of Pascal's triangle. So for example, that's k equals 0, k equals 1, k equals 2, etc., etc. Okay, so as you can see, we can use binomial coefficients to calculate the coefficients of all of these terms. Okay, so just show you a quick example. What happens if I have 4 choose 2 or 4 and 2? So n is 4, k is 2, so I'm on the n is 4 row, across to the k equals 2, and we see it's equal to 6. Okay. If you were to get a calculator out and calculate the factorials, you will also find that it equals 6. So what I can do now is if I write a plus b to the power 4 with these binomial coefficients in, what I have is I have 4, because I'm on the n equals 4 row, and when k is 0, I have 1, so I have 1a to the power 4, a to the power 4, and I also have a b to the power 0. Now, any number raised to the power 0 is simply 1, so this I could have just missed out this b to the power 0, but I put it in here just so it's easily understandable. Okay, adding on to that, I have, okay, so I'm still on the n equals 4 row, and now I have the k equals 1 binomial coefficient, so that's the 4. So 4 and 1. And this time it's a cubed b, power 1, plus 4 and 2, a squared b squared, plus 4 and 3, a to the power 1 b cubed, and finally plus 4 and 4, a to the power 0, b to the power 4. Okay, so as you can see, there's a fairly consistent pattern here. On the binomial coefficients, we always got n equals 4, and on the k value for the binomial coefficients, it starts at 0, 1, 2, 3, and 4. And also the powers of a and b also follow a pattern. Okay, so what I can do is I can write this down in summation notation. Okay, so what we have here is summation, capital letter sigma, k equals 0 to 4. Okay, so we have a binomial coefficient of 4 and k, because that will change. A to the power 4 minus k, so when k is 0, a to the power 4, when k is 1 is a to the power 3, and so on and so forth. And also b to the power k. Okay, so that's exactly the same as that expansion written there. Okay, well, what about when instead of to the power 4 we have to the power n? Well, written in exactly the same way. We have sigma notation, so k equals 0 to n, and we have the binomial coefficient n in k, a to the power n minus k, and b to the power k. Okay, if you wanted to expand out the summation, what we'd have is n choose 0, a to the power n, b to the power 0, plus n and 1, a to the power n minus 1, b to the power 1, and so on and so forth until we get to the other end, and a to the power 1, b to the power n minus 1, plus n and n, a 0, b n. Okay, and this is what's known as the binomial theorem. Okay, very, very useful, allows us to multiply out brackets with two terms to the power of. So let's have a look at an example. Okay, earlier on I was able to quickly expand out a plus b to the power 3. Okay, so using the binomial expansion or binomial theorem, we have 3 and 0, a to the power 3, b to the power 0, which I'm just going to ignore. And we have 3 and 1, a to the power n minus 1, where n is 3, n minus 1 and therefore is 2, b to the power 1, plus 3, choose 1, a and b squared, plus 3 and 3, a doesn't exist anymore, and it's just b to the power 3. Okay, so if we evaluate those binomial coefficients, we have 1a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, and that's the binomial theorem.